guys. I want to talk a little bit about the path of the sun today before we get into our lesson on seasons, which we'll be working on a little bit later on. So just to kind of review some of the things that we've been talking about with the celestial sphere, we've been focused kind of on the stars with that rotating Sky Explorer lab. Now I just want to focus on the sun specifically and its path across the sky. So just general things that you should obviously know. The sun rises in the east and the sun sets in the west. And it's always not perfectly east and not perfectly west, except for 2 days out of the year, which we'll talk about a little bit later on. Another thing that you obviously should know by now is that the sun reaches its highest altitude, or its angle above the ground, at solar noon. That's the highest point above the ground. And for anybody in the northern hemisphere, if we were looking for the sun at solar noon, we're looking to the south. Okay. If you're in the southern hemisphere and you're looking for the sun at solar noon, you actually look north, just the opposite. So that's something that we'll take a look at with some diagrams as well. One thing that we did early on in the year was just measure shadows, and you can make a sundial pretty easily. Just collect data throughout the day on a sunny day. Set up a stick in the backyard and measure the shadow along the way. This is a sundial that's located on the Cornell University campus in the engineering quad. This is a very precise sundial that measures to the nearest minute. So it's pretty cool. It's just a cord stretched across there, and then you see a shadow cast onto this half of a ring here, and you'll see what time it is. I used to pass by that all the time on my way to my teaching classes and my geology classes. Anyway, so that's kind of a cool thing that we can do, and maybe we'll do some activity with that. All right, so the sun's path across the sky is obviously due to the motion, the rotation of the Earth, the spin of the Earth. And as you guys know, the Earth rotates counterclockwise in the northern hemisphere. So if you're looking at this, okay, you're looking at the northern hemisphere, it is rotating counterclockwise, okay? And the actual spot where the sun rises and the sun sets every day depends upon two things. Well, it depends upon your time of year as well as your latitude. So that's kind of an important fact there, this idea that the exact place where the sun rises and sets is based upon the time of year and your latitude. Okay. Now there are 2 days out of the year for everybody where the sun rises exactly east and sets exactly west, and therefore we have 12 hours of daylight as well as night. Okay, so those are the equinoxes, vernal, and autumnal, and things that you probably already knew. Okay, because we've talked about this already. This just shows the sunset on different days of the year, and we'll be talking about seasons later on, so this is related to that. If you're looking at this picture, and this is sunset, and you're looking to the west, and over here, this is the December picture. This is what it, let me just present this really quickly. This is what it looks like in March. Okay, so on the equinox, it's perfectly in front of you, and then there's June, okay, and then there's September, and then back to December again. All right, so again, March, and then June, and then September, and then December. Again, same location at sunset. The difference is exactly where is it setting. It's different throughout the year. When it's on the equinox, September and March, it's perfectly setting in the west. So this spot right in front of us is west. Okay, here in June, notice how it's more up here. Okay, so which way is to the left in our picture? Is that north or is that south? And then December, going back to this picture, now it's more over here. Okay, so there's a slight difference there. Is this more to the south or more to the north? Okay, it's not exactly perfectly east and not perfectly west. Okay, so we'll get back to that and we'll answer that question in a second. Now, the important thing is the path of the sun around us is really a complete circle. And what we see is when it's daytime, when it's above the horizon. And what we don't see is during the nighttime, obviously. Okay, and the rotation rate, this is also an important fact, the rotation rate is 15 degrees for every hour. And that's because the Earth is spinning, right? And there's 24 hours in a day, and we spin all the way around once in a day. 360 degrees divided by 24 will give you 15 degrees per hour. And therefore, we see things move across the sky at a rate of 15 degrees per hour. it's the rate of our rotation. Okay? Now, let's take a look at some celestial spheres, because this will help us determine different times of the year. So we can see in this diagram here, and you need to be able to identify these diagrams and what season it is. Notice sun rises in the perfect east, due east, gets up to an angle or an altitude of 48 approximately in New York, and then sets directly in the west. Zenith above him, north is up here, south is up here. Notice how the sun goes into the southern sky. So this is the vernal equinox. Now, it would be impossible to tell the difference between this and this. They are identical. This is the autumnal equinox. Again, rising perfectly east, setting perfectly west. The only way you'd be able to know whether it's spring or fall is based upon the things around you, right? The foliage and so on, whether you have flowers blooming or flowers dying in the fall. So that's not going to be told by the celestial sphere. So let's go to summer, and what does it look like in summer? So notice sunrise is over here, and it's to the northeast, and then it takes this really long path up to an angle of 71.5 or so in New York State, and then it sets in the northwest. Okay, a really long path means really long day. Approximately 15 hours of daylight on this day. Okay, the first day of summer solstice, June 21st. And then we have winter. Winter, we have this short path, rises in the southeast, angle of about 24 or so, and then sets in the southwest. A really short path means really short day, maybe about 9 hours of daylight on this day. Okay, so just note the difference between all these seasons. The path of the sun determines the length of daylight. It also determines where the sun's going to rise and set, as well as the altitude of the sun above the horizon. Now, I didn't point this out. I did this last week. I pointed this out, that there's a 23.5-degree difference between the equinox path and the summer solstice, and the winter solstice is down here. It's 23.5 less. And that's important. That's based upon the tilt of the Earth. Okay, just a couple of other terms before we kind of wrap some things up here. These are basically different types of what we call twilight. So twilight is that time of the evening or in the morning when the sun has just set, or when it's just starting to rise, and it's just before that, and you can kind of see some light. So there's 3 different types of twilight, which I'll define on the next slide. We have what is called civil twilight, nautical twilight, and astronomical twilight. And if you were to consider each one individually, it's based upon where the sun is located relative to the horizon. So we're on top of this surface here. Okay, so imagine there's a person here. Okay, you're standing on the surface and looking at, there's a very funky looking dude. Anyway, got a long neck. He's looking at the sun. The sun is right here, let's say, on the horizon, and it's about to set. Okay, there's my sun. They're looking at it. They can see it. It's just setting. Once it dips below the horizon and it gets into this area right here, from here to here, we call that civil twilight. That's 6 degrees from the center of the sun below the horizon. Okay, that means it's still kind of bright out. It's not super bright, but you can see stuff. Okay, and if it gets any lower than that, it's going to start getting darker. Nautical twilight is 12 degrees below the horizon, and then astronomical twilight is 18 degrees below the horizon. So you can kind of tell the difference between all 3 of them. It's just based upon how far down it's dipped below the horizon. Once you get past that, it's nighttime. Okay, so let's take a look at these definitions. Let me erase my screen. All right, so you can see the definition of civil twilight is the time when the sun is 6 degrees below the horizon. We call it civil because it's kind of related to humans, us, our outdoor activities. We can still do stuff. It's still bright enough to see, but you might need some, like, your lights on in your car, and the street lights might start coming on. Nautical twilight's related to ships. When they sailed around, they were unable to distinguish the horizon on an open sea. And so that is what we call nautical twilight. It's pretty dark. It's hard to distinguish stuff. You can start to see some stars at nautical twilight. Astronomical twilight, that's when it's like completely dark. And at this point, you can see pretty much all the stars in the sky, and you need your lights on. You can't really see anything in front of you, okay, without some artificial light. So those are the different types of twilight. All right, so some simulators. just to kind of help you with understanding the path of the sun across the sky. There's a few that are listed here. One I want to show you in particular. So let's go to this one. It's called Solar System Scope. I actually put this under topics. So if you go to topics, go to sky viewing, I embedded it right in the topic. So you can try it there, or you can go to the website, solarsystemscope.com. And this is a really handy tool. So if you take a look at this thing, you can look at, it plays music too. You can take a look at the solar system as a whole, and this is the current date and time. And I can speed up time and watch the planet's orbit around the sun. This is really handy for that purpose. Okay, and it's something that's kind of cool and fun to play around with. So you can play around with the solar system model here and see how the Earth is spinning. And every day it spins, we see the sun go across the sky. That's what we were talking about. Okay, it's also revolving around the sun too, which is something we've talked about in the past. Let me go to something a little bit different. This is another option. You can go to what's called the Night Sky Viewer. And this kind of looks like that Stellarium program that we were playing around with last week. So if you take a look at this, let's just forward time a little bit. Let's actually go to actual time. So this is October the 16th. And you can see where the sun is located. And if I fast forward time, you can watch the sun go across the sky as well as all the other stars. Okay, so it's getting up to an angle above the horizon, probably around 40 degrees, and then it's going to set over here in the western sky. It's going to be more to the southwest because we're heading more towards December now. We're getting closer to the winter solstice. Now, if I forward time even more, actually, let's just change the date. We'll change the date to, let's see. No, not that. We don't want to do that. We want to change the date. Okay, so let's go to December 21st. There it is. The first day of winter. And if I fast forward time here on my, I'll go back in time actually, because it's December 21st. I want you to notice how short of a day we have. So the sun's going to rise, and I want you to notice where the sun rises. It's going to rise in the southeast down here. And when it rises, it's 5 o'clock in the morning right now, 6 o'clock. 7 o'clock, starting to get bright, twilight, right? And there it is. It's like 8 o'clock in the morning by the time it's rising. And then notice how high it gets in the sky. It's not very high. It's pretty low in the sky. And then it's going to set in the southwest over here. And it's going to set sometime around, let's see when it actually sets. Notice getting dimmer and setting right there. Okay, it is 16:06 p.m., which is 4:06 p.m. It's setting at 4 o'clock in the daytime. That's terrible. Okay, we have a really short day. Obviously, if we change this to summer, then it would be a much longer day. So that's kind of a fun thing to play around with, just to kind of give a perspective on this. So guys, that's kind of the basic message. I know I've talked about some of these things already, but I figured I'd give you a little lesson on the path of the sun, and you're going to be doing an activity related to this today. Okay, so that's it.